In this video, we'll discuss on the right quotient of languages. Let there be two languages, L1 and L2, which are considered to be regular. The right quotient of L1 with L2 is defined as L1 slash L2 will be a set of strings X. Now, how to define X is where L1 and L2 plays a major role. Every string in or at least a few strings in L1 can be divided into two substrings X and Y. And let us try to find the suffix of the L1 Y to be a part of the string in a string L2 in the language L2. Fine, that is how it is. So we try to define it as L1 slash L2 is a set of strings X such that XY is in L1 and Y is in L2. Now, how do we define it? Let L1 be a language which has a string AABB, which is divided into two parts, where AA represents X and BB represents Y. And now you have a string AABB, which is X and Y, where YBB is a part of L2, and therefore L1 slash L2 is AA. Now, how do I do it? Is if L1 and L2 are regular, then L1 slash L2 is also regular for any regular languages which we take in. Therefore, regular language is closed under the quotient, under the right quotient operation. Now, how do we define it? Is if the L1 is represented by a regular expression A closure B A closure. So we'll try to define it. You say you will have A closure on Q0 as a loop on Q0, and then B to Q1, and then we have on A to Q2, and then a self loop on A. Now, what is this Q3 all about? Q3 is all about the trap state, what we were talking in. Q0 has two valid transitions on both the input symbols A and B, whereas Q1 has only one valid transition on A. The invalid transition on B leads to the trap state Q3. And Q2 also has an invalid transition on B, which leads to the trap state Q3. And Q3, since it's a trap state, any transition on any further alphabet symbols will lead to Q3 itself. L2, we have just enumerated the set of strings. You have a single A because you have a B closure, and A, B, B, and so on. So you draw the DFA for the L1, and for L2, we'll just enumerate the strings. Now we'll talk about the intersection of Q0, L on Q0 intersection L2. How do we do that? It's very simple. You talk about, you consider every state as the initial state. First time, let us take Q0 as the initial state. If Q0 is the initial state, you take any string from L2. From Q0, it has to reach the final state. So if I take A, on reading A, it will be there in Q0 itself. There is no way I can go to Q2. And then on AB, you can reach only Q1. If I read ABB, A is Q0, B is Q1, and the next B goes to Q3 for the trap state. And therefore, L in the L of Q0 intersection L2 is a null set. What about Q1? Q1 on the first string A can lead to Q2. And therefore, L of Q1, Q1 is the start state here. And L2 is A. Similarly, L2 in L1 of Q2, intersection L2 is A. You can reach the final state. And therefore, you have in state A. Now, the next one is to mark the final state to identify L1 slash L2. Now, from Q0, if you remember, you can have from Q0 to Q1, you cannot reach Q2 because L of Q naught intersection L2 is a null set. Whereas L of Q1 intersection L2 is A, L of you have some valid sets strings in it. And therefore Q1 and Q2 will be considered as the final state. So that is how it is defined for each node. Look for a walk on any element, at least one element from L2 to Q2, because Q2 is the final state. And those states will act as the final state. So the new final states are Q1 and Q2. So we'll try to define, it is A closure B for the first case, and it is A closure B, A closure for the second case. And that is where we have two different regular expressions. One is which moves till Q1, and this is till Q2. This is, I have just optimized it. Fine. So this is your L1 slash L2. So how do we define it? Is very simple. I'll reiterate it. We'll draw for L1. Meantime, we'll also write or enumerate the strings what we have in L2. And then what are we supposed to do? Let us find a walk. What is a walk? From a particular state, reading a particular string, you have to reach the final state. So now to find L1 slash L2, we'll not meddle upon the initial state. Rather, we'll find new final states. So let me take, I have enumerated just 3 strings. And the first string, reading from Q naught, I'll never be able to reach the final state. Reading the second string, there is no possibility of reaching the final state. Reading the third string, I end up in a trap state. And further, I end up in a trap state. And therefore, Q naught will not act as a final state. Whereas from Q1, when I read A, you reach the state Q2, that is final state. And therefore, I'm not checking for A, B, I'm only checking for any one of the string. So Q1 on A, it reaches Q2, and therefore Q1 acts as the new final state. Q2 on A also reaches Q2, which is a final state in L1, and therefore Q2 also acts as a final state. So in general, Q1, Q2 acts as the final state for L1 slash L2. We have one more example where L1 is defined and L2 is defined. So I draw the diagram for L1 and you have the trap state to be Q5. You try to identify the new states. So the new states would be, I'll put it in this perspective. You have the L2 as B per M. M is greater than or equal to 1. Sorry. From Q2 on B, it moves on to a non-final state. From Q1 on B, it reaches to Q2. So Q1 acts as the new final state. Q2 on B also it reaches Q2. The rest of the states won't. So the new final states would be Q1 as well as Q2. Whereas this Q4 will not act as a final state. So the new final state would be Q1 and Q2 for the given diagram. This is how you try to identify the right quotient.